Chapter 15, problem number 18. We are supposed to find the pH of 4 different substances, and the first one that we are finding the pH of is a 0.1 molar HONH2 problem. And they give us the Kb of this problem, which indicates it's going to act as a base. And so if I start with an equilibrium expression, this is not a strong base because it's not a group 1 or 2 hydroxide. When I put a weak base in water, it's going to want to take a hydrogen from the water, giving one more hydrogen with a positive charge and leaving a hydroxide for the water. We're going to make an ice table for this problem, and it tells us we are using a 0.1 molar, so that's my initial concentration. I don't need to worry about water, and I'm going to have none of this or the hydroxide. The reaction is going to proceed with the forward reaction to start because we have no products, and I will end up with 0.1 minus x, x, and x. Because this is a weak base, we can write a Kb expression. The Kb is products over reactants raised to their coefficients. One thing I just want you to be aware of, that the charges on the right side should be equal to the charges on the left side. So a plus and a minus becomes neutral, and the left side is neutral. And then I can put in my values. So x times x, or x squared, over 0.100 minus x. Again, I can assume that this is much, much smaller. The Kb was given as 1.1 times 10 to the negative 8th. And so when I solve for x, I will get 3.3 times 10 to the negative 5th molar. Now this x is representing the hydroxide ion concentration from here. And so if I take the negative log of that, that's the hydroxide. If I take the negative log of the hydroxide, I will end up with the POH, not the pH. And so negative log of my value for x, and I will get a POH of 4.48. The question, though, is asking us for the pH. And so for the pH, you have to take 14 minus the 4.48, and I will get 9.52 as the final answer. Just one note about the significant figures. The concentration, actually I might have a mistake here. The concentration here has 3 significant figures, so I should actually be able to have 3 digits to the right of the decimal for my pH. I do not have that because I maybe wasn't as careful as I should have been. I will say on the AP test, though, typically speaking, they say 3 sig figs should be fine. But if they give you 3 total significant figures in the problem, you should be able to get 3 digits to the right of the decimal in your pH. Then the second part of that question, part B, wants you to find the pH of another substance, 0.1 molar HONH3Cl. This is the salt, and I know that because I have this chlorine on with the ion that I had in the previous problem. And so the first part of this is salt breaking up, and we know if we take this and break it up 100%, I'm going to get HONH3 plus and Cl minus. And this HONH3 plus is exactly what I had in the previous problem. And so that is the conjugate acid of the base that I had, the weak base that I had in the previous problem. So I'm going to write this reaction as an acid problem. HONH3 plus is a weak acid. It's the conjugate acid from the weak base we had previously, HONH2 plus H plus. And so I can make an ice table for this substance. I started with 0.100 molar and none of either of those. The reaction will proceed forward to start, and it's 0.100 minus x, x, x. Now, this is a weak acid. It's the conjugate acid from the weak base in the previous problem, And so I can't use the Kb, I need to have a Ka. However, there's a relationship between Ka and Kb that says this, that the Kw is equal to the Ka times the Kb. So I can find the Ka if I take the Kw, 1 times 10 to the negative 14th, and divide it by the Kb, which was 1.1 times 10 to the negative 8th, and I will get a Ka value of 9.1 times 10 to the negative 7th. Okay, so when I write my Ka expression, I'm going to have products x squared over reactants 0.100 minus x equal to that Ka times 10 to the negative 7th. And again, I will make the assumption that x is much, much smaller than the 0.1. So when I solve for x, I get 3.0 times 10 to the negative 4th molar. I want to divide that just to double check by 0.1 and make sure it's less than 5%, and I believe it is. This time the x corresponds to the H plus concentration, so pH is equal to negative log H plus, and so that's negative log 3 times 10 to the negative 4th, and I will get a pH of 3.52. Again, I believe I should be able to have one more digit to the right of the decimal because of the 3 sig figs here, but I do not have that in front of me. So that should be the end. Notice the difference in pH is quite great, that in part A the pH was very basic, and in part B here the pH was much more acidic. Then in part C, it asks for the pH of pure water. That one you should be able to do pretty easily. Pure water, we know, is a very, very weak base and a very, very weak acid that breaks into H plus and OH minus. And we know that the Kw for that is 1 times 10 to the negative 14th. And so that the H plus and the OH minus are going to is the common ion part, which is going to lead us to buffers in the next lecture. And so the last part, though, we are going to mix the two substances. We have a mixture of 0.1 molar HONH2 with 0.1 molar HONH3Cl. So it's a weak acid, and a weak base, and a salt containing the same ion as that weak base. So for this one, we know the salt is going to break up 100%. So I can just make a mental note of that, or I can just write that out, or somehow indicate that I'm going to have HONH3 plus and Cl minus, and I'm going to have 0.1 molar of each of those things. I know that Cl minus is not going to affect the pH, so I'm only really concerned about this acid anion. So here is a weak base, though. So I have HONH2. You put that weak base in water. It's going to take a hydrogen away, and we're going to have HONH3 plus, and leaving a hydroxide behind in the water. Now I make my ice table. I'm starting with 0.1 molar of this. I don't need to worry about water. And I'm starting with 0.1 molar of this. No hydroxide. Because I don't have any hydroxide, the reaction will proceed forward. And it'll be 0.1 minus x, 0.1 plus x, and x. Now this is a weak base, so I need to use the Kb. And the Kb is products over reactants raised to their coefficients over 0.1 minus x, and we're going to say that the x is much, much smaller so that we can ignore it. Also, because these are both 0.1, I have x is equal to the Kb, and since Kb is 1.1 times 10 to the negative 8th, that is also x. But remember now, x corresponds to the hydroxide ion concentration. So I can find the POH, which is negative log of 1.1 times 10 to the negative 8th. And from that, I can say POH plus pH is equal to 14, and I would be able to get my final answer. The final answer should be, I actually don't have that calculation. .04. Hopefully you got that. Good luck.